Today, we'll start today with the applications of Python in economics. Very unusual combination that we talk about because uh, not recently, few years back, people have not talked about Python could be applicable in economics. Python could be applicable in management, or Python could be applicable in accounting or finance. But yeah, Python has a large and vast pool of applications. So no matter what field you are working, Python is applicable. So my name is Chintan Patel, and Madam President have given the brief introduction about me. So we'll start with what you are going to have today. So first we will start with uh, obviously why you should use the Python. Uh, Fortunately, we have a solid answer for this question. As we move forward, you will eventually get to know that why you should use the Python in field of economics. Then, particularly why Python is getting famous in economics and why you cannot ignore Python anymore. Then, we'll see some comparison between Python, R, and Stata. Again, I will teach you some basics of Python and then some libraries, which are essential part of using economics as an application for Python. Then we'll do some hands-on practice, and you don't require to install anything. I will show you what to do with your Google account and how you can use the Python only just to have your Google account and a phone and a laptop. And then we'll talk about some case scenarios, and we'll end up the session by taking your questions. But three major categories where economics is getting divided and Python meets as an applicator for economics. So this is a very clear path that we are going to follow as an agenda for today's session. In between, if you have any question, you can always write in chat. I'll happy to answer. And furthermore, I will take the questions in the last two. Okay, very exciting journey we are going to have today. So very first question, why Python? We are not habituated to ask why questions. When we when we learn in school or when we learn in undergraduate or the postgraduate, we are kind of afraid to ask the question, which is double inverted comma called why. Okay, why we are learning this, why we are doing this, why we like someone or whatever. We don't question in terms of why. So why this webinar is happening, why we are gathered here, and why we have to talk about Python today. So very interesting thing that Python is a very readable syntax. So any programming language, there are two things important, very important. The first one is syntax. Syntax are the set of rules, how that language must be written. So that are the syntax. We write English, we write Hebrew, we write Russian, we write any other language. There are certain rules. Okay, those set of rules are called syntax. So Python has its own syntax. The second one is logic. Logic we have to build. As we think, we have to build a logic that what operation should we use, how that operation can be interpreted by Python. So the logic, as in when you practice, it getting much stronger for you. But the syntax are fixed, predominated rules that we cannot change. But it is pretty much readable. So Python is very simple. As you write in English, you can write in Python. Very easy to understand. And even if you don't know Python, it is very easy to start with. No other programming language can give you that freedom that Python can give. So if you are a beginner, you have not worked with any programming language, it's okay. If you have not heard about Python, it's okay. you can start because it's very friendly for beginners. Then there are wide community support available. Okay, you just have to put your problem, or you have to just put your code into the community, and that community will teach you what to do, how that code works, what other things can you do with your code. They will just teach you to play with your code. Okay, so there are large users, number of users. When I was giving a session in the morning, I just realized that in 2023 there were 11.5 billion Python developers worldwide. So in 2025 the number may be reach around 20 million. Okay, so that many support is available for you. Very versatile applications. Any field you are working, biology to economics, Python is for you. Very simplistic way to use, that includes the data analytics, that includes web development, that includes app development, software development, game development, AI, machine learning, deep learning, whatever you say, Python is always there. So there are numbers of applications. Then there are some libraries. We are going to use some libraries today. We are going to see some hands-on also. The number of libraries are there. Basically, libraries are the powerful tools already mounted in the Python. You have to use whatever library according to the field. So there are particular set of library for economics. We are going to see all the libraries today, and some of them we will going to use also. Okay. So once you use the library, you don't have to worry about the long complex code. The library is designed for that particular complex task. Yeah. And the last one is there are tools like Jupyter Notebook and PyCharm or Google Colab. All those tools, those are learning and experimenting tools which interact with the Python and gives you the output. So all of these reasons are enough to make Python suitable for any field. Okay. So this is the generalization idea about why we should use the Python. Now the question that comes is why we should use Python for economics. Uh, we have been trained in R, we have been trained in Stata, we have been training other softwares, but then suddenly Python comes, people talk about Python, that's why we should use Python. No, that's not the answer. So very specifically, libraries like Statsmodels, linear models, ECOML, regression, panel data, causal inference, everything that you imagine or that you have calculated for the economics or any branch of economics, there is a specific library in Python which can work for you. So there are hundreds of libraries for economics and its allied branches. Python simplifies the data cleaning or survey manipulation or census or financial data sets. As in economics, we work with large surveys, large number of data set, maybe in gigabyte data, but that is very uh, compatible with use of Python. Okay. Very complex data can be handled Python very. Then you say we have to do the time series analysis. You can you can do with the microeconomic modeling. You can do inflation tracking. You can do forecasting. Anything that you have done with the use of any other software, Python can do much better and in much user-friendly way. Okay, we will, as an time passes, we will gonna see that how this can be used. Okay, very interesting thing and very specific advantage of using Python for economics. We can do web scraping. Web scraping is nothing but scraping the data or fetching the data, real-time data from the website or web pages. So let's say if you want to have data from World Bank or IMF or RBI or any other things, you know their URL, you know their web pages or website, that data can be fetched at that point of time with the use of Python. So there is a bigger advantage of using Python compared to other platforms, that they cannot work in this tremendous amount of data in real time, and with the use of web scraping. Okay, you can share your analytics using Jupyter Notebook. You just have to share like in Google Doc or Google Sheet. You just press the share button. Here also you just have to press the share button and write the email ID. That code will be shared to others. So very easy to share. We can use somewhat visualization. We can see the graphs, we can see the charts, 3D graphs, moving charts, all the things are easily module with the use of Python. That's, as an economist, we required. So this is the scenario where economists should use Python for all of this. No other platform or tools can support all this facility. So that's why an economic should use the Python. I think this part is very much clear, and this is the setting agenda for today's webinar. And that's why Python is becoming so much popular, because of this facilities Python can provide. Okay, let's move on. Some other reasons, but with some data. So Python is now the second most used language in academic research. Think about the second most used language. People were not talking about Python before 5 years, but it is now the second most used language. Okay. Over 60% of job posting for economic analyst roles in development banks and think tanks list Python as the required skill. And this is not I'm saying, this is the World Bank job data says. The 60% of job posting, think about it. If you want to work as an economics analyst, you should have the Python as a required skill. Python is a core skill for IMF economic training program. So that World Bank or IMF runs some programs for training the new economics, or let's say for some faculties who are working for Python, some student or postgraduate or doctoral students who are working for economics, they run the program for economics with the use of Python. The workshop or the policy modeling or financial risk modeling, everything includes Python as a backbone. So this is pretty much clear now. If whether you are working in any field, particularly in economics, you must have a skill of Python programming. Once you write a Python programming in your CV or resume, you are getting highlighted. You are far ahead and far better than your competitors. Okay, so this is the setting agenda for today's webinar. Okay, so as we know, this is the economics, and as far as I know, economics involves some theoretical modeling, the empirical analysis and research, and then last it makes a policy. Okay, we generally use data or R or Excel or EBSU. So this is our traditional tool that we usually use. But then a word, the fantastic word called data science comes into the picture. And what about data science? That it involves data wrangling, statistical modeling, machine learning, and visualization, and blah blah, whatever fancy name you can call about. That why data science are getting popular, because it enables the prediction, the classification, regression, causal interference, and so on, but at a very large scale. Okay? So this is economics, data science, and then comes the Python, because Python is a backbone of the data science. So it's like a general purpose programming language, very simple to learn, but very high capacity of handling that large data set. And then you can enable and reproduce the research, task getting automated. You don't have to recode again and again for every single task. API and web scraping is always there. You can build fantastic colorful dashboards and simulations using Python. And once we combine all of this it becomes like this. So once the intersection of economics, data science, and Python make you the modern economist. This is the scenario where we get to know that yes, Python is very essential, Python is very useful. If we don't learn skills like Python in today's world, we will not able to cope up what others are demanding from. So this is in general a Venn diagram kind of thing where the core is a modern economist, but you must have the skill of Python. So are we good as of now? Moving forward, why economists can't ignore Python anymore? We have that habit that if something new comes up, we try to avoid. We are like that. We are getting trained like that. We are comfortable with R. We don't want to leave the R and we don't want to learn Python. If you are working with eViews, if you are working with R, Stata. So once you are getting comfortable, that comfort zone will restrict you not to use Python. But they have their limitations. Of course, you can choose those over Python according to your compatibility and comfort. But think about if you use Python, you are doing much faster work, much easier work, and much recognizable work. Okay, so let's take the three scenarios. First scenario, what we were doing in earlier times when we have been labeled as a traditional economist. Nowadays, some of them also continue with that tradition. But what was the scenario over earlier times? We have to collect the data in survey. That was manual service. Sometimes that survey feeling goes up to the month. Okay, that's those data were there with us. Then we use Excel. We just have to convert the data or whatever survey result we got manually we put into the Excel. We have paper notes with us, and then we put some basic econometrics and in Stata. That is the tools. Those were the tools we were using in earlier times. What were the workflow? We download the data. We do some basic data cleaning in Excel. We run some regression models in Stata, and then we paste that output into Word or PowerPoint. That was the workflow in earlier times. Then we know about that was very slow, clumsy, lengthy, siloed process, and very hard to reproduce. And nowhere we're talking about the automation at that time. So as a result, there was a lot of limitations. And by the time insight were ready, the economy had already moved on. Once your paper is published, we have a new economic era before we produce our research output. So that was the things were there in earlier times. This is exactly uh, one should not work scenario. Now what happens? The scenario two, that is the current reality. We have some modern challenges with us, economic challenges, rapid growth, slowing down economy, unpredictable recessions, all this, but the tools remain old. Okay, the challenges become modern, but the tools remain old. Now what is there? The data is available, but in abundance. And APIs are there, dashboards are there, real-time feeds are there, but all those data are fragmented, not in a combined one-click go data form. Then we still use data and Excel, but they have their limiting power. They have their capacity of computation. They cannot handle the unstructured data, where 80% of the world data is unstructured. Think about 80% of the data is unstructured, and when your tool is not able to handle such large amount of unstructured data, what are you gonna do? You don't have enough computing capacity to deal with those large data sets. What could be the workflow? We just copy paste between tools. Once we do with some analytics in one tool, we just copy paste the data in another tool. And it is very difficult to merge the multiple data sets. Okay, it's very limited for visualization also and automation. Some level of visualization and some level of automation is there, but still very limited. And there is no support for this. As a result, what happens? We have a large, huge, big data, but it cannot scale or collaborate efficiently. That is what is the limitation as of now in the current scenario. More the data, more the pressure, but tools have not kept up. This is the current scenario that uh, most of the economists are facing difficulty with. But what if we use Python? So that becomes our third scenario. So once you use Python, you become a Python powered economist and everything gets sorted. How? Because you can have the live APIs like World Bank data, like IMF data, like RBI data, where every day there is something new. You can use the panel data. Web scraping is also possible. You can use Python. Just you have to learn about the new libraries. And you don't have to code about the libraries. Libraries are already there. You just have to use it. That's all. Very easy programming. What could be the workflow then? You just have to write the script. Script meaning a small little program for cleaning, merging, analysis, analytics of data. You have to run the simulations. The simulations are already there where the business scenario can be fit. Regression models or machine learning models are already being, and then you can have a real-time dashboard like IMF update the data and your dashboard get updated simultaneously. That is how a workflow could be if you use Python. Your output could be reproducible, very fast. You can share your code, collaborative, 3, 4, 5, 10, 50 people can code simultaneously. Scalable also. These are the advantages. As of now, we don't see any limitations for this. And with the Python, you are not just analyzing the economy, but you are building the tools that shape the economy. This is the three scenarios where the traditional economist or the current economist cannot compete with one economist who knows how to work with Python. I think pretty much clear, and I'm going little slow or make you aware about the basics, why we should use a Python, because there were a lot of questions once we start that I'm using R, why should I use Python? I'm using this software, why should I get involved myself into Python? But after this slide, you will get to know that yes, Python is very useful, having many advantage over traditional tools. And once you start working with Python, there is no go back. You will always gonna use Python. You're gonna love that. Okay. So this is kind of comparison, the evolution of economics toolkit. Okay. So I compare with traditional economist, the modern economist, but no Python, and Python power economics. So this is kind of summary that we have seen in last three slides. Data access to tools, to speeds, to scalability, to reproducibility, to output, to collaboration, to the insights. All these aspects are getting much more easier, much more scalable if you use Python. Very interesting thing is when you compare the speed, Python is the fastest among all possible softwares that you think about. Okay. When you think about the web scraping, no other tool can compete with Python. When you talk about the visualization, moving chart, 3D plots, no other tools can compete with Python. So this is overall I hope that you fit into the fourth column, that is Python Power Economist, and you able to learn much more and do much more in terms of whether you are working as a in a any allied field of economics. Okay, let's see some comparison also Python R and data, because many of you must have question that what could be the advantage over all this software. I have taken R and Stata because, as research says, R and Stata both were the traditional choice for economics. But now Python is becoming more popular in economics compared to this both. So let's see the comparison. So when you see the cost, because money is so important for us, uh, for everyone. So when you see the cost, Stata is paid, whereas R and Python are free. But when you compare R and Python in terms of interdisciplinary use, Python's interdisciplinary uses are much higher than R. You can use R in statistical modeling and visualization, but what if you want to do some visualization? What if you want to do some academic research writing? What you have to do for the policy purposes? What I have to do some econometric modeling, the regression modeling, the classifications. All this possible in Python. Although R can be used for that, but which one is faster? Obviously, Python is much faster than these two. This is the comparison, and once you see uh, the comparison, you will get to know that there are much uh, advantageous uses for Python compared to R instead. Okay, moving forward, uh, I have interesting plot for you. So that plot is programming languages versus uses in economic research paper. I'm showing the percentage. So it's the comparison from 2015 with 2024. So in 2015, see the R, 45% people in economic research writing paper using R, but it reduced to 25% in 2020. See the Python. In 2015, only 10% were using Python, but now 43%, higher than Stata and R, were using Python. This is just a one graph that I'm showing you, that popularity of Python, specifically in economics, when it comes to research paper writing, R&D, it is getting increased day by day. And something which is getting popularity, we should be aware of, we should be known to, we should have been learning to. Okay. So how we should go with that? From where we can go with the learning purpose, or uh, the world known universities are introducing Python in economics. There are some examples. Harvard Business School uh, introduce a subject called data science for economics. The subject code is EC109. LSA's MSc Econometrics now includes Python-based labs. Or universities that I belong to, IIM Ahmedabad or JNU or Ashoka universities are offering Python in their economic courses. All the renowned universities in economics, they are offering one in or another way Python as a tool to learn economics in a very, very concise manner. Okay. So let's start with basics of Python. We talk about Python so much. We talk about why we should use Python in economics, why Python is getting popular in economics, why whether you belong to economics or allied branches, you should be doing some coding in Python. Okay. So once now we are entering into technical details about Python. So let's see what is there for you. So first, we will learn tech terminologies. The first terminology that comes is variable. Uh, some of us are known to this word variable. The variable itself is a self-explanatory word that have the value that is varying. Okay, so that is called the variable. It stores the data, any format of data, whether it's a whole number or a fraction number or a string or a sentence or a boolean, any kind of data that has been stored, the storage container called the variable. So like if I write income equal to 50,000, so income is a variable name and its value is 50,000. Very simply. If I write country is equal to India, the country is my variable name and India is a value. See, there is no double inverted comma when I write numbers. But when I write string, that is alphabets, there are inverted commas. Inflation rate is equal to 4.5. So inflation rate is a variable name and 4.5 is the value. Okay. So it can have integer number like whole number like 50,000. It can have a fraction number that is a float number called 4.5. It can have a string also. So there are certain rules how you can name the variables. Okay, it cannot start use the number. So you cannot write 8 income. Okay, so variable name cannot be start with the digit. Okay, and there is a second rule, you cannot use the space. But yes, you can use the underscore. No other special character can be used, but yeah, underscore you can use. So this is uh, the variables holds the values, numerical value or number or alphanumerical values or alphabets. And okay. So these are the basic terminologies that I am trying to teach you. The first terminology is variable. The second terminology is operators. So in mathematics, we write plus symbol for addition. So for subtraction, there is a symbol. For multiplication, there is a symbol. For finding the exponential, there is a symbol. All those mathematical symbols converted into Python, and all of those are called operators. They perform specific calculations. They perform comparison also. Let's see some of the operators. So GDP is 3,000. So if I want to calculate the growth, what could be the formula? So let's say I'll multiply GDP with multiplication operator, or let's say any factor like 1.07. You can take any number. So GDP is variable. 3,000 is the value for that variable. What I'm doing, I'm having another variable called growth, and I'm doing some mathematical operations. I'm multiplying GDP to a number which is 1.07. So that star you see in between GDP and 1.07 is called multiplication operator. So there are many operators in the Python. This is the one example. Second example could be like is underscore recession, another variable name. Growth is already we have calculated in the upper line is less than 2800 is less than 2800. So that less than compares both the values. Okay, so that's why it's called the comparison operator. Doing again a mathematical operation also. So whatever mathematical operations you do, you perform with the help of one symbol that is called the operators. So any mathematical formula that you apply in economics have to have those operators. Then another terminology called function. So let's suppose you have a big task to do. Let's suppose you have to perform to calculate the income tax. There are numbers of variables associated to calculate the income tax. There are numbers of conditions associated with your income tax. There are numbers of dependent variables associated with the uh, income tax. Let's take a very simple example just to make you understand. If I want to draw a circle and I want to color in that circle, I have to use two functions. Why two functions? One function can perform only one task. So there are two tasks. Drawing the circle is one task. Coloring the circle is a second task. So one function will always draw a circle. Just we have to give the radius as a variable. And the second function will always put the color in that circle, whatever color you wish to have. Okay. But every task has one function. If you want to perform three tasks, you should have three functions. Why function we should use in Python and why this facility is much popular in Python? Because once you create a function, you don't have to repeat the code. It automates the task. So let's say you want to find the mean value for one column in your Excel sheet. You don't have to write the code every time for that mean function. You can put the function, whatever column name you want to give, just feed in that function. That function will give you the mean. Just have you don't have to write again and again a code for doing a finding a mean value. So functions are the reusable blocks which reduce the number of lines in code, automate the task, and very popular. Let's see an example. If I say def is a keyword for defining a function, and after defining a function, you have to give the name. Let's say I give the name as double. I can give any name. And in bracket, there is a variable name called x. Okay. What that function does? So it returns x multiplied by 2, or let's say x raised to 2, or x to the power 2. Okay. Whatever number we feed in x, it will be multiplied by 2. Okay. So if I put the number 3, because my function name is double, instead of x, now I'm putting a number. What could be my output? So 3 into 2, the output would be 6. Okay. There is one little information. If you write any line with hashtag in Python, it will become a comment for Python. And Python will not read any comment. It will not perform any coding if you start the line with hashtag. This is for your understanding. Like I write hashtag output 6. This is for my understanding. Okay, this is not the Python code. It will not read. Python will not read this. Okay, so as I said, functions help you to automate the task. Okay. Every time you don't have to code, you just have to define a function. So now what happened in this example, if I want to double any number, I don't have to write a code again. I just give the number to double. The function's name is double. So if I give any number to that, it will get doubled. Yeah. Let's see one more word called library. This library is a collection of pre-written functions. If you have so many functions, all the functions together become a library. Like a book library have many books, different books. So in this library of Python, there are many functions already pre-written by a Python programmer or coder. You can use very easily. So for that library, we will use uh, again a keyword called import. So import NumPy. So NumPy is a library, okay, already predefined. As is again a keyword. As is nothing, just to use to rename something. So what I'm doing here, I'm renaming the NumPy as NP. In some of the cases, the library names are so long. You cannot use those so long library names again in your uh, code. Otherwise, it looks clumsy. So what Python says, that change the name. You can give the shorter name. You don't have to worry about the long name. You just have to give the short name. You can use the keyword called as. So import is a keyword for calling the library. NumPy is a library name. As we are using to change the library name. Now the new name is n. So let's say my data is 246. Okay. What happens if if I want to calculate the mean value of the data? Now see, mean underscore value is a variable name. Okay. What it does, it calculates the mean value. But for calculating the mean value, what we are using a method. And what is the name of method? Is a mean. Method's name is mean. How we can get to know this is method? Because there is a dot. So whatever comes after a dot is the name of that method. There are numbers of methods associated with numbers of libraries. This method is from the library called NumPy. Okay. So NumPy has a full form called numerical Python. So when you are working with numbers in Python, you have to work with this library. Okay. So once you are familiar with and practicing much in Python, you will get to know about various methods and various libraries. We are also going to see some of the libraries. Okay. And the last one. So earlier we learned that one variable stores the one value. But in previous slide, we see data stores three values, 2, 4, 6. Three values are being stored in data. So that variable can save only one value, but a list can save more than one value, like this. So GDP underscore list. Now it's not a variable. Now it become list because it has more than one value. It has 2000, 2100, 2300, so on. It can have multiple values. Okay. This is very helpful because in when we use Python in real-time data, we have numbers of data into one single column, and that one single column is a list for Python. That's why Python is very important. Okay. There are some libraries which is going to be used. You can take the screenshot, you can click the picture. Those are the libraries which you have to have learn when you are working with economics. Every library has its own application. Okay, these are the core numeric and scientific libraries. NumPy, it's called numerical Python. Scientific Python called SciPy, PyTorch, and QPy. These are you must know about the DSG's model or deep learning, forecasting, all this computation. These are the fast computational tools or high dimensional models when you are working. See how these libraries are getting code, you don't have to worry about. You just have to use it like we have used NumPy earlier. For data visualization and communication, we generally use Matplotlib or Seaborn or Plotly, but can also use Altair and Bokeh. Bokeh is specifically used for economic indicators like inflation trackers and fiscal simulators. Bokeh is very important when you are working with all these things. There are networks and symbolic mathematical library. Network X is the library name. Senpai is another library name. So when you are working with microeconomic theory or microeconomics or game theory or algebraic equilibrium, you must use the library called simulation pi or SimPy. When you are working with econometrics and machine learning, like let's say you want to work with ARIMA model or SARIMA model or penal data or standard economic workflows, you have to use the state model. This state model library have all the features of Stata in Python. So you are familiar with Stata? Those all the features that you have worked can be used very easily in Python with the use of this library called Stata. Then there are Keras, there are Pyros also. Pyros is for the Bayesian modeling, for structure estimation and uncertainty quantification in economic models. So this is libraries that when you are working for economic modeling. Then there are other libraries also, GeoPandas, when you are doing some regional kind of analytics, some region kind of analytics, some caste-based analysis, some analytics which are geospatial. There are Dask also, Numba also. Okay, Numba speed ups the simulation, like Monte Carlo methods in pricing model. We know about when we calculate with R, it's very clumsy, it's very slow. But with the use of Numba, it is very fast. For optimization, vision, and web scraping, there are some more libraries. Beautiful Soup is very popular library when you are scraping the information from internet. Any website they can scrap, but it should be legal. Yeah. So let's start working with Python. But before we work hands-on practicing, we need to know about something that is called integrated development environment. These are two types of environment. One is external that you have to use it, and one is cloud-based. You don't have to worry about the space or the memory in your laptop or in your phone. So this is kind of a software platform which allows you to write, test, and run your code. Okay, so that includes four things. The one is code editor, where you write the code. Second is interpreter. Interpreter checks your code, and the errors that are likely to be produced are to be marked by the interpreter. Then there is a debugger. Debuggers are not compulsory. Some ID can have the debuggers, some ID may not have the debugger. It will help you to fix the error, because now interpreter will give you the type of error, but debugger also gives how to fix those errors. Yeah. And sometimes depends on what ID you are using, it will give you some visualization tools also. Okay. So now the next question comes that what are the different integrated development environment in which we can code for the Python? So there are few. I have listed four for you. The one is Google Colab. The second is Jupyter Notebook. Third is VS Code. And the fourth is Spider. All of this can be used. I recommend using Spider once you become a intermediate level of programmer in Python. But if you are beginner, if you don't know how to work with Python, or if you have not worked with Python, you should start with Google Colab or Jupyter Notebook. But my choice for today's session is Google Colab, because Jupyter Notebook we have to install separately. But today we are not going to install anything. We just use one facility that Google provides us. It's called Google Colab. Why we should use the Google Colab? In the beginning, I told you that we should focus on why. Whatever we are doing, we always ask the question why. So Google Colab is your digital research laboratory. Okay, you can write codes, you can write equations, you can run them, you can generate the output. You don't have to install anything. You just have to have a Google account, which I suppose we all have. There is no setup needed. Only browser is enough. Even if you don't have Google Chrome as a browser, that is also okay. Okay. Then Google provides the free GPU support using large model. There are already libraries that have been installed. That those libraries are pre-installed. Have we worked with NumPy? We talk about Pandas. We talk about Matplotlib. All those libraries are already pre-installed in Google Colab. You can share your code just by clicking and adding the email ID. It's great for sharing the code. You must have shared the Google Sheet. You must have shared the Google Documents. Likewise, you can share the Google Colab file also. And it's very good for beginners. Okay, you can upload Excel file, you can upload CSV file, you can run regression model, which are going to run today, and then we can visualize instantaneously. We are also going to visualize too. So that's why we will use the Google Colab. So let's start something. I'll tell you how to use the Google Colab, but before that, what I'm trying to teach you that how we should code. Okay, so generally code looks like this. Let us understand first code and then we'll do coding. Okay, so what I'm trying to do is here, I'm finding the basic GDP analysis. Okay, so my first line of code is import matplotlib.pyplot as PLT. As I said earlier, import is a keyword. Why we use the import keyword? Because we have to call some libraries. What libraries you are going to call? The library name is matplotlib.pyplot. Whole name. Okay, the full form is mathematical plotting library. Okay. So matplotlib.pyplot is a whole library name, but this is very lengthy name. I have to change it. So I will put another keyword called as, and whatever name I want to give, I'll give the PLT. Okay, you can give your name as a new name. It's okay. Then I have two lists. One list, the name of that list is years. The second list, the name of that list is GDP. In the first list, we have 5 different values: 2018, 19, 20, 21, and 22. And then we have a GDP in another list: 2.7, 2.9, minus 3.4, 5.7, 6.1, y minus because there is a COVID time. Now the next portion, PLT dot plot. Now what is PLT? It is a renamed library. We gave the name in the very first line PLT. Whatever name you have given, you have to write it here. Then, as I taught you, dot comes for the method. Okay. So dot plot. The plot is a method. Method for whom? Plotting. We are plotting the graph between years and GDP. Okay. So x-axis there will be years by default, and GDP there will be y or y-axis. So this is the command for plotting the graph. Now, what if we want to give the name for that graph? So there is a method called title. So plt.title. Okay. Now, what if we want to give labeling to x-axis and y-axis? So there is a method called xlabel and ylabel. So you can write year as an x-axis label, and you can write GDP growth percentage, whatever you can write. So in double inverted comma, whatever you write, it will be printed on your screen. All this graphing and plotting, we have to see on our screen. For that, another method is called show. So plt dot show is the method for showing the graph on your screen. Now let's start some coding in your computer. If you are working, if you are on a laptop or a system, follow what I'm doing on the screen. And if you don't have right now laptop or personal system, you can use your mobile phone also. Okay, so for this, sometime I'm just switching off the screen So I'm stop sharing this and I will tell you what to do next. Okay, my Google Chrome browser screen is visible to you. What you have to do, you have to go to the Google. If you are stuck in any of the step, let me know. I will repeat for you. So once you go for Google, you just have to write Google Collab and have to press the enter. Once you press the enter, very first link you have to click, and then your screen for Google Colab will come. If you have worked earlier, whatever work you have done, it will be shown to here. Otherwise, it will be a blank. Okay. So I have already created a file for you. So I will open that file. If you want to open a new file, you just have to click here, new notebook, and the new notebook will come and appear. It will take time depending upon the Google Cloud storage capacity. See, the screen comes. You don't have to worry
Sorry,
about the release notes.
sorry, Shinton. I just want to check if everyone is following. So maybe if you can just check if everyone's on the same page as you before we
Okay,
move on to
okay,
the next. Yes, thank you. So that
yeah,
everyone is able to practice. Thanks a lot.
okay, okay.
Audience, when you guys are ready, just give us a thumbs up so that Mr. Patel can continue. If you are struggling to get on this page, just raise your hands and he will gladly go back so that we are all on the same page. Thank you.
Okay, great. We can go ahead. Yeah, okay. So once this screen is visible to you, let's say I want to type my name. It's like print and then add a print Patel, and you have to press this button. It's the play button. Once you play this, it will start coding, debugging for you. And once it's done, you will get to see the output. See, this is the output. Interesting. There is one more feature. Okay. Let's say if you want to code something else. So there is a button called plus. So once you click on this button, it will give you another cell for coding. Very interesting thing. See, in a very lame manner, they have written start coding or generate with AI. So let's click on generate with AI. We have to follow the norms. Yes, continue. And let's say uh, generate a code for addition of two numbers. Will it work? Let's see. Great. See, the code is ready. The AI generated code in Google Colab. Don't have to worry about. Let's say I want to generate a code for simple calculator. Enter and see code is ready. It's that easy. Python coding is for you. Okay. So we'll not take a much great help from AI because we need to learn how to code for that. So let's get back to that GDP uh, plotting. I have ready code for you, and that's there. So this is the code. that we have already learned, the highlighted one. Okay, that is what we have run. Once you press this, you will see the output. This is my output. See, it start with 2018, then it 2018.5 take by Python automatically. 2019, 19.5, 20, 20.5, 21, 22, whatever. The year is written because I have labeled X as a year. GDP growth percentage is written here because I have labeled Y as a GDP growth percentage. And then the title GDP growth over years. You can right click and you can save the image and you can put it in your document. Very easy to use. Okay. Now come back to the presentation. Okay, here we go. So this is what we have plotted already. Okay, the next one. So let's say I want to know whether there is inflation or not. Okay, see, I have told you, whatever line has been starting with the hashtag, Python don't read it. Okay, Python take it as a comment and Python really doesn't care about what comment. So hashtag ask user for input is a comment for Python. Python will not run it. Second line, rate. Rate is a variable name. Now, we have talked about the data type like integer, the whole numbers, float, that is not the whole numbers. But what if we want to take the input from user? Okay, let's say an example. I want to take the input from user to addition of the two numbers. User will give me two numbers and I will give the addition of that two numbers. Here also, inflation rate is to be taken from the user. So there is a command called input and the inflation rate percentage. Okay. So whatever we write in inverted comma will be visible for the user, and whatever amount user is entering will be stored in a variable called rate. Okay. Now again, the third line start with hashtag. It's a comment, not a code. If is a keyword for condition. If rate is greater than 5, if user have given the number greater than 5, what would be the printing as an output? High inflation. Consider policy tightening. Okay, that's that there is a message that we are supposed to print if the inflation is greater than 5. What if it is equal to 5? Inflation at the threshold, monitor closely. And if it is less than 5, or let's say else, below inflation or the policy space available. Okay, let's run this code again. I'll share the coding file with you. Don't worry about that. So here we go. That was the code that we have brought. So once I run this, see, I'm getting asked, enter the inflation rate. Why I am getting asked? Because now I become the user. So whatever inflation rate number I have in percentage that I will give. Okay. So let's say I'll write 6 and then enter. See, it is showing high inflation, consider policy tightening because my number is greater than 5. You can code here also. Okay, I'm taking 5 as a moderate inflation rate. You want to take it 3, you can take it 4.5, whatever number you can give. So this is called conditioning in Python. So there are three words that can be used in conditioning for Python. One is if. After if, you have to give the condition. My condition is rate should be greater than 5. Then the second is elif. You have to give multiple condition. You can use the elif. As many elif you want to use, you can. So elif, 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 whatever. And in the last, you can use else. So all those condition may not get true. Then what you have to do? So that you have to put it in an else part. Okay, great. uh, Going forward, I have another code for you, and that code is here. It's a calculate of average income. Okay, so I have a list of, let's say, 30,000, 45,000, 50,000, 60,000. I want to calculate the average. Very simple mathematical formula for calculating the average. What we do, we sum of all the elements of the list and then divided by the length of the list. So let's say sum of the elements is like 30,000 plus 45,000 plus 50,000 plus 60,000 and getting divided by the 4. Why? Because there are 4 elements in the list. Okay, and then it will get calculated. The another program, I'll show you 3-4 programs and then I'll run it for you. Like currency conversion. So there is a currency called United States dollar having value 100. Then the exchange rate is 83.2. How we can convert INR from USD? We just have to multiply USD with the exchange rate and we'll get the value. So here the star symbol is an operator, multiplication operator that we have talked on. Simple tax calculation. We use if else again that we have used earlier. Okay, this is something new. Okay. Let's see the coding file so you'll get to know better. So once you have opened up the Google Colab, okay, this is, I think I have to zoom a little bit. Okay, here comes. So incomes average, I'm finding the average as sum of income and divided by the length of income. So if I run it, I'll get the values. So average value is 46,250. Remember that word output is always a number if you are working with a number, and it is always a float number. So dot zero will always be there because a integer number cannot work as a float, but a float number can work as an integer number. Then we have plotting. Okay, so that is the code for plotting. Import pandas. When you are working with panel data, you have to use a library called pandas. That nothing to do with the panda that we see on the cartoon. The matplotlib, because we have to plot something. Let's plot the CPI inflation data set. I have data. Again, I have two lists. One list from 2018 to 2023. Second list, there is a CPI inflation. The random numbers like 4.9, 3.7 is the CPI inflation. And I want to plot it. Okay. And this, the title, X label, Y label, we have already seen it. So if I run it, I'll get a graph that looks like this. See how beautiful it is. You can change the color. You can change the type of the graph. You can change the size of the bar. You can do anything in the visualization that you want to do. Okay. Let's see next program. Okay. This is the unemployment data. Okay, I have taken the example related to the economics. You may take the example according to your field or allied field of economics. Uh, this is another plot called the line plot. Okay, so this kind of plotting and graphing is also possible in the okay, I have a question for it. Okay. Okay, going forward, I'll share the code with you. You just have to press the run button, and I'll show also a material for you where you are beginner in Python. You can just go through that material and get to know how to learn Python in depth. Okay, see this, what I have done. This is very important feature of Python. What I have done, I have taken the data from internet, the live data. Okay, there is something, a URL, a data is there. I have fetched that data from that URL. So you can see the URL is here. This is the URL where the data is there. Okay. This data is about India's GDP over the years. Okay. And then actually it's a master data of having all countries GDP, but I have taken for India. So what I have done, I have fetched the data from the URL. I have filtered for only India and sort it by the years, and then I have plotted it. Okay, so I have not downloaded the data. I have not downloaded any other external softwares or applications. I just use the web scraping. I have taken the data from internet, filter it for my country, that's India, and sort it by the year. And once I run the code, it looks like this. This is the real data. Okay, I have data up to 2023, 22. So that's how I have plotted India's GDP over the years. Okay, the GDP is in current US dollar in terms. Okay, so you know that we have crossed uh, 3 trillion US economy. Okay, this is what it looks like. Second example I have taken. I have fetched the GDP data for India from the World Bank site. Okay, I have used external help called WB. For that, I have to install another library. And for installing any libraries, you have to use this command pip install. Okay, if you don't know about which library to be installed, you can ask the Gemini. Gemini will tell you, okay, and it will give you the out. So this is another real-time data from 2005 to 2022, where I have taken the data from World Bank website and I have plotted the graph. Another real-time data that I have taken the data for petrol price in one of the city that is very popular in India, the capital city, that's Delhi. Delhi's petrol price over the time from let's say 2017 the mid of 17 to mid of 24. So this data is already being there at the government website, and I can fetch those data very easily with the use of Python. And the last one, I have taken the data of CPI inflation versus human development indices, the global human development indices. So CPI versus Human Development Indices, and my country stands here. You can see the India's return in very small font, and all other cities countries are there. So this is called the scatter plot. We have seen the line plot, we have seen the bar plot, and this is called the scatter plot. Scatter plot will give you the information about uh, the outlier. Okay. And the last example that we can visualize is the model. This is the simple linear regression model, the BMI versus disease progression model. Again, I am taking the data from internet. I have not downloaded any data. My web scraper that I have developed in the Python that have using the data. So in the models, what we do is we divide some data into training data and some data into testing data. More or less, we follow the rule of 80-20. 80% data is in testing, 20% data is in training. Okay, testing and training. This is what it looks like. And then our own very favorite things, prediction, classifications. Here I have used the random forest classification. So this is how you can do classification. This is how you can do regression, plotting, web scraping with the use of Python. When you are going to use with R and other platforms, it will be very difficult for you because there are no AI integration. Here you can have the AI integration as well. Even if you get some error in the code, let's say if I write this and I like print in bracket, let's say I forgot to end one inverted comma and I write hello world. And I write this. So that will be an error. Why error? Because I know I have not ended with double inverted comma. But let's see, you don't know about the error. What you gonna do? You gonna click here. That is explain error. Another feature of Python and another feature of Google Colab. If you just press it, and then it will give you what to do. So it will explain the error and it will give you how to focus. See, the error is selected cell in syntax error caused by missing closing double quote. So that it will tell you what is the error, how you can solve the error. So see, it will give me the line. Instead of this line, you have to write this line. So I will add here and then I will run it and then whole world is mine. Hello world is getting printed. Very easy, uh, very familiar to use AI and coding together. It will explain the code also. It will explain the error also. Okay. Great, great. Okay. So have we seen many of the uses of Python in day-to-day life, in economics also? Those are some examples. The code will be shared with you, so you can use it in your Google file, Google Colab file. Okay. Now let's talk about the typical economic applications of Python. The one very interesting and very familiar thing is econometrics and statistical modeling. Okay. So let's suppose your problem statement, your policy purpose is estimating the relationship between economic variables using regression and hypothesis testing. What you're going to do and what could be the example of it. So Python, like IMF and World Bank use the Python to model how inflation reacts to interest rate changes using penal data econometrics. So we can run the regression model to estimate the price elasticity or fiscal multiplier effects. This could be the example. You can use this example in your research. So this is kind of a case scenario uh, uh, where you can use Python and its applicability in the economics. So IMF and World Bank already using Python for the inflation reacts with the interest rate changes. Second scenario could be forecasting and predictive analytics. Now, what to predict? So predicting inflation or GDP growth or exchange rates or defaults. But for that, we need to have historical data for the years and years. RBI uses in our country, India, there is a bank called Reserve Bank of India. That bank controls uh, almost all the economic activities in the country. They uses the time series model that already being built on the basis of Python code, the ARIMA model and SARIMA model. The forecast for inflation trends over the monetary policy decision, how decision is going to affect on the inflation trend. For an example, if you want to build a 12-month GDP growth forecast model, you can use the past data. You can build it with Python. Very easy. The third case scenario, that is the labor market analysis. A very important analytic feature is there. Let's suppose we want to analyze the employment trends, wages, and demographics and skill gaps. We have seen in COVID-19 times, this is very important because of the migration happens. So CMI's unemployment data. This is for my countries again, the example. Uh, your government body may have released the data or may not have released the data. Some NGOs may have worked on it, but there is some data about the employment trends, about the wages, about the demographics, about the skills. For an example, if you want to analyze a female labor participation rate changes after COVID across your country, or let's say in my country, there are different states. All the demographics of the states are different. If I want to analyze this, I can easily do it with the Python. The fourth case scenario, would be in finance domain. Let's say public finance and taxation studies. Very important for any economic activity. So let's say I want to analyze the tax burdens, or I want to analyze the subsidy impact, or budget forecasting, or fiscal deficit trends, like OCDs researchers do some research on tax policy changes, how the effect of tax policy changes on a household income distribution that they are doing with the help of Python. And for an example, if I want to model a GST policy, GST is goods and service tax in India. So modeling a GST policy scenario, that how GST is being changed over the policies, and I want to visualize their impact on different income groups, I can do it with Python very easily. And the last scenario that is nowadays very getting very popular is economic behavior simulation. How a group or the individual or a specific region based or religion based people will behave under certain circumstances in economic activity. So agent based modeling we can do with the Python. Market simulation we can do, or the consumer behavior under different policies we can do. Like behavioral economics always work with simulations and uh, policies they are using to see how spending or labor supply may get changed under the policies. For example, if you want to see a market simulation where agents choose between saving and spending under the inflation shocks, you can design the simulation very easily with the use of Python. Okay. So where uh, we are at the end of the session, so I'll talk about a little bit. This will be probably the last slide in terms of theory. Uh, there are three big categories of economics that I have divided. The first one is health economics. We know about this because in COVID times, the terminologies in health related to economics become very, very popular. Okay. Uh, but there were limited features, but that digital transformation occurred in times of COVID, made the world required to use the Python or simulators in different situations to generate different situations. It is not only applicable for health economics, it's also applicable for businesses. So let's say if you want to, what if lockdown started 2 weeks earlier? You want to analyze this scenario, you want to simulate this scenario, you can do it very easily because now we have the COVID data with us and now we have the power of Python visual. The second category is environmental economics. It's also getting very, very popular because we talk about sustainability, we talk about the shared responsibility. When the World Bank and UNEP use a Python to simulate the effect of carbon tax policies in Asia Pacific economy. See, we have not thought that Python can be used in this scenario also. Because of its visualization capacity, Python visualizes the climate impact under various industrial scenarios. Those scenarios may have not occurred, but you can visualize that what if this scenario could have occurred. And the last one, that is development economics. JPL, we know about MIT, we know about those where those are using Python for RCTs. RCTs are the randomized controlled trials in the experiment. This is very important. And they have designed and simulate with the use of Python. Very interesting thing that they are working on. But in the regard of India, the central government have launched a scheme called direct benefit transfer, where the money for certain schemes is getting transferred to the beneficiary to their bank account directly by the government. So let's say I want to replace this scheme with a very better scheme. So how I can evaluate that this scheme could perform better in comparison to the existing scheme. So development economics sees this comparison with the use of Python, where you can compare the policy outcomes, where you compare the scenario outcomes, and then you can analyze what could be the output if this policy have been applied. So this is the three uh, differentiating allied economic branches that is getting very popular with the use of Python. And this is what I have to say. And there is something people have said about Python. So uh, if you know about this guy, you can write it in chat box if you know about this guy. Very quickly, 10-15 seconds for you. Okay, so this is Professor Thomas Piketty, this very popular book, Author Capital in 21st Century. He talk about Python in terms of to understand inequality today, you need data, and to work with data, you need tools like Python. Yeah. Then there is one more person. We all know about this lady. It's Dr. Shell. The former chief economist of UK Foreign Office, and she was associated with JPAL. She told that Python has changed how we simulate policy impact at a scale from randomized control trials to the national rollouts. Okay, so it's not only me who is advocating using Python for economics. Those are people. We know about this person also, Dr. Paul. Professor Paul have said that economists who can code will shape the next generation of policy, and Python makes that possible. Okay. And after that, in 2018, he won the Nobel, and in 2019, she won the Nobel. She told, without Python or R, our work in development economics wouldn't pay. Those are the important people who talk and advocate about using coding and Python in economics. So we should listen to them. We should start coding. You should not get afraid of coding. Python is very easy. You have already learned some other tools. So this is very easy in comparison to those tools. and I raised the webinar here. I am open to take any questions, and this is the academia and corporate connections that I am currently working. And yeah, if you want to connect with me, these are my details. And thank you so much for joining. Once again, I'm thanking the Madam President and the whole team of Young Global Economist Society, and specifically Mr. Udit Maheshwari. Thank you. I'm open for the questions.
Thank you so much, Mr. Patel. This has been very interesting, very enlightening, very mind-boggling. Just if I were to just go back to one chat before I make my comments, there was a request to go back to a slide. One of the slides that was in the library, I think slide 1, that was in the library. Let me just check.
Okay.
Okay, hold on. I'll tell you now.
We're talking about this.
Okay, can I see the first slide of the libraries? So
Okay.
yeah.
This is the first slide of libraries, the core,
Okay,
mechanical,
I
and scientific
think
libraries.
it was from Anonymous. Anonymous, you can take a screenshot. However, guys, this video is recorded and it will be posted on our YouTube channel, so you can always refer back to it if you guys want to do your practice and exercises. Just follow us. I have shared the links to our LinkedIn page and the link to our YouTube channel. We also do have Facebook page, Instagram, and Twitter, where we communicate information that is upcoming and also share the link to our recording so that you guys can go back and refer to the session. Yeah, man. Wow. So I do have before, if there are any further questions, you guys can just write them in the chat and I will just look at those. I think maybe Mr. Patel, if you see anything, you can obviously
Yeah,
respond.
I got three comments.
Okay.
The two comments are almost similar, that they are asking for PPT and code, as you have answered already. And second is the gratitude message call. Thank you. So not other than that.
Yeah, so we cannot provide the slides. The slides are the property of the YGES Society. However, this video will be available on our YouTube channel. Just follow us on LinkedIn and our social media pages so that you know when it's been uploaded and you guys can go and do your exercises. So I do have so the nice thing that I appreciate with the session is that actually I was going to ask what's the difference between Python and Stata and eViews, which is what were taught in terms of modeling when we were in undergrad, even in master's level. So I don't even think our universities are at the level of Python yet. So I'm just glad that you did show those comparisons in your first few slides. And that's great. So my next question is, with AI coming on board, how is it going to disrupt? Is it going to complement? Is it going to augment Python? Or is it completely going to take away the role of human financial modeling? And then just a follow-up question on that. Okay, maybe you can answer that before I get to the follow-up question.
Okay. So to answer that question, as I stated, whatever AI model that we use, whether it is generative AI or whether it is agentic AI or whether it's neurosymbolic AI, whatever AI model is nothing but a code. It's very
Yeah.
well designed logical code. It will never replace the human intervention.
Okay.
Never. I work with AI, but the code that I wrote is the logic that I have developed. AI can do the syntax formation. Like I show you the Gemini can help in doing the coding, but then the logic building has to be done by the human. So as of now, I don't see in the near future that AI is completely restricting the human interventions. It will not going to happen sooner. But yeah, as you are going further, we have to learn how AI works, and then we have to modify our skills to compensate and complement the AI. That is what.
Also, we should complement AI. But I
Yeah.
mean, we're the one who tells AI what to do. So I don't know. this world that we live in. Because AI exists because of us, robots exist because of us. We are the input. We provide the inputs to whatever outcome that we want. But then we also go back and say, oh, but it's going to take our jobs. But yet we're the ones who create these things that are, at some point detrimental to our survival. So the follow-up question I have is, if you were to advise someone to do Python, maybe as a course or an advanced financial modeling certificate, which one would you propose?
So I propose start slow, gather every details of your logic building. Instead of directly jumping to the code, first take a pen paper, draw the flowchart. Once you are ready with your flowchart, transform into the model, and then the last portion comes in the coding. So let's suppose you want to do a financial modeling for a country like a diverse country like India, where we have so many states. In the state, there are so many regions where we are diversified. One region is completely different from other region, and I want to
Yeah.
do some financial modeling and forecasting, including forecasting that tells me the prediction of financial economical activities in my state or in my country or in my city. I don't go directly on coding. I'll start with the modeling, and I'll start with very basic flow chart, that how it affects, what are the parameters that going to be moduled. Is there a dependent variables or are there some independent variables? How they are associated? What are the correlation factors? I will calculate all this, and then I put all this data. Let's suppose I have historical data and the variables. I put it all this into the model. The model will tell you based upon certain parameters that this region, this state, or this whole as a country will perform uh, uh, a particular thing, a particular number will be generated. You can obviously take the help of AI if you are not clear what are the independent variables and what are the dependent variable, but you are the best person who knows your things very clearly. So before jumping into coding and financial modeling, I always prefer to have a flowchart in your mind, a model that what could be the input and what you are looking for as an output. It could be a one model output, it could be a multi-model output, but what exactly your goal is. As Python is object-oriented programming language. So Python focuses on object, not the procedure. How you are getting that object is not matter for Python, but that object should be reached is what is the core for object-oriented programming. That's why Python is much simpler. If you see the C code or a Java code or a R code or a Stata code, Python is much simpler. And why people prefer AI coding in Python? Because it can easily be understood by a layman also.
Okay. Awesome, awesome. So I was going to ask, but I'm glad you went into it, because some of the examples you were using were more quantitative, and we know that research can also be qualitative, and that is where policy comes in. And so I see that Python also is a tool that we can use for the development of policy. And I am in the health sector, and there's this talk around having an NHI in our country, which is basically free medical aid for all citizens. And obviously, we have existing medical aid providers which are pushing back. So it would be interesting to have an understanding of the long-term impact, or what's the word? Not the trade-off, but yeah, the cost benefit of the proposition that we are proposing within. And I mean, South Africa is not a first world country. I know other first world countries do offer free medical aid. And just understanding those dynamics, it would be interesting to actually know the viability thereof and if it will really have positive impact, not just on lives, but just of this in the sector as well. Yeah.
Great, great. I've been following what the government of Africa specifically doing in terms of medicine and healthcare. and
Mm,
recent years they have doing a great things
mhm,
in terms of the policy development for healthcare and medicine, specifically
mm,
for women and specifically who is malnutrition children. So
mm,
even for the, I have read somewhere for the pregnant woman, they have different policies for healthcare. So what I'm suggesting is we can simulate so many scenarios using Python.
yeah,
So
yeah.
those scenarios can be fit into different aspects. And once you evaluate the best fit scenario, even Python can tell you what could be the best fit scenario according to the so many factors. See, when we talk about the free medicine and healthcare facilities, there is always a burden on uh, other side. So
Mm,
government has to look for many other financial aspects also when they are rolling out a policy. Uh, and I have read some of the policies that is tremendously working since ages, but
mm,
now some modifications are required. But those
yes.
modifications are not being discussed in a group of some experts, but instead of that, those experts could be trained and Python could run, let's say, hundreds of scenarios and then tell you the best case scenario that this policy will work in this manner and this could be the output and this could be the other side burden on finance and economic activities. So yeah, not only quantitative but the qualitative work that you would like to do in terms of policy generation to policy implementation, Python is there to support in terms of simulation and scenario based simulation.
So does it use proxies instead of actual numbers when it comes to a qualitative model?
So Python use the historical data. It it it
Okay.
uh, uh, it generates the number sometimes just to forecast something. It generate some scenario which we could not have think of it out of
Mm,
the box, but
yeah.
those were based on numbers if you have historical data. But if you don't have, let's say, much data to put it in a simulation, you can always rely on Python that it also generates some data and fit the model. Yeah, sometimes it generates that data by its own. Otherwise, in most of the cases, it uses the historical.
Okay, great. So as is similar to other modeling softwares as well. So what is the future of Python? Should we invest in Python, or is there something that's going to come that's going to be better than Python?
So
Yeah.
if you are asking to me about investing in Python, I'll tell you, have faith. This is going to be future. This is sooner going to replace all other tools, and because this applicability is not limited to any one field. So I work with AI. I work with data science. The Python is a backbone. So if you work with economics, biology, even the neuroscience have the Python simulators. If you are working with, let's say, physics and electrics, if you are working with construction and civil engineering, there
Mm,
are numerous applications of Python. So one must learn Python at least up to the level where they can understand the code or what code is going to give you as an output. At least that intermediate level proficiency in Python is required nowadays,
mm,
no matter which field you are working with. So I must suggest heavily invest in Python, not only as a skill but as a product also. So will give much more return if you have not think of.
okay. So we do have a question from Elijah Kai. Okay,
Okay.
and then from Shim as well. So Elijah is saying, assume that I have basic Python programming language. Is there any opportunity I can get to practice my knowledge? Elijah, I don't know if you'd like to ask. It's not clear. I don't know. We don't know what your knowledge is. So would you like to just unmute
So
yourself
Elijah,
and
if
ask
I
the
can answer
question?
your question. if you, as far as I get to know that you are talking about practicing your current level of Python programming. See, there are numbers of applications and numbers of website which can give you the rough code, and then you have to find some code mistakes. You have to rerun your code, and you can do a lot of practicing and enhance your knowledge in Python. That's the one thing. Second, you can do practicing by seeing some courses that might YGS community may offer, and other experts that courses are there. So always start practicing with very low printing hello world tool, like simulating the financial models. This is what I suggest to Ella.
Elijah.
The second question is, okay, second.
Yes. Elijah, I see your hand is up. Would you still like to ask a question? I have allowed you to speak. Elijah. Okay, I'll move on to Kim. My question is, how can we differentiate data scientists from? Okay. Hi, Elijah.
Yeah, can I talk?
Yes, you may.
Okay, I was asking on the, you know that I have some basic and some knowledge in maybe Python programming. In what way or in which way can I use my knowledge to either earn or to either utilize it in either helping other people or doing some kind of stuff for earning for living?
Okay, so as I already answered that you can use your coding experience or the knowledge that you have. Try something intermediate level of coding. Try something making a simple model or a simple simulator. Let's suppose you want to design a scientific calculator with the use of Python. Start from that. You just have to talk about what kind of mathematical functions you are talking. Just simulate that. And once you are ready with those simulations, try different scenarios. Like try adding logarithmic function, try adding trigonometric functions, try adding geometric functions, and so on. So start with very basics, go on the simulations, do code every day, enhance your knowledge, and use that is in business applications or whatever field that you are working with. Try to connect those skills of Python and how you can transform into the business insights. I think you are mute.
I am. I am. Yes, I am. I thought I was still unmuted. Okay. So the question is, how can we differentiate data scientists from economists? They seem to be similarities.
Okay, there are some overlapping, of course, because nowadays economics using machine learning model, regression models, classification model that we are using earlier times. So data scientist is also a thing where we very much focus on machine learning and deep learning. Where in economics, we don't care about that deep learning or machine learning portion. But yeah, in economics, we talk about models which are fairly related to the finance and economics. But in data science, we don't care about what field we are working. As a data scientist, if you are working with healthcare, all the health terminology should be aware about that data scientist. If that data scientist is working in defense domain, all the terminology should be aware by the data scientist in defense domain. So data scientist is a very huge umbrella in which that data scientist could be working in the field of economics, could be working in the field of defense, could be working in the field of healthcare. So yeah, it's a big umbrella. Economics and the data science may have overlap, but then uh, there would be a thing which can differentiate in terms of skill.
So do you see Universities transitioning. Do you see universities transitioning from Stata eViews to Python when it comes to our econometrics training and learning?
Sorry,
Do you see in the future, do you see in universities transitioning from Stata eViews into Python as a form of learning? Or will they always be married to the traditional
yeah.
method?
Of course, of course, of course. As I gave some example of Harvard, MIT also, those are the leading front runners for the educational training changes. So they have already introduced the courses of economics with the use of Python, applications of Python. So those things can be we are seeing in future in India also. Certain universities are getting involved themselves in training and uh, uh, giving some certification courses in terms of how to use Python in economics. So yeah, in 1 or 2 years maximum, you will see many of the universities putting themselves in this pool and in this competition where the applications of Python is being used in economics. Yeah.
Awesome, that's great. Are there any more questions, guys, from the audience? Do you want to raise your hands? There's nothing in the chat. All the chat questions have been answered. I'm not sure if you're seeing any hands. Let me just check. Okay, there's no hands from the audience. Yeah, so I guess then we've come to the end of our session, and I truly do not think this is the end of our relationship with you, Mr. Patel. This is definitely, this is a skill that we need. It's a skill that I believe our cohorts in our society, our members, need. And like we already know that even in our academic curriculum, we don't use Python, we use Stata or eViews, but when we have to apply for jobs and in the market, your R's, your Pythons are a requirement. So we are looking forward to a long-term relationship, a partnership with yourselves to the benefit of our members. And yeah, we'll obviously see how we organize that, plan that, and structure that going forward. But it was a very insightful session. We definitely need to practice this by ourselves in our own time, to get the hang of it. And hopefully the people that have applied today can include this as a skill, and hopefully we'll be able to land them that job opportunity that they need in order for them to make the difference that our communities and society needs. So I am very appreciative. Thank you, Udit. Shout out to Udit for facilitating the arrangement and the session, and just constantly poking me to just allow things to move at the pace that Mr. Patel needed for us to be able to be here today. So thank you very much to everyone. Guys, do follow us on our social media pages. We are on LinkedIn. I have shared the link on the chat. I have also shared the link to our YouTube channel on the chat, so that when this video is up, you guys can go back and use it as a practice session as well. We are also on Instagram, Twitter, and Facebook, and we do have a lot of exciting speakers coming up and programs that we would be running towards the end of the year and the beginning of next year for our members. And we are a global institution. As you can see, I'm in South Africa and Mr. Patel is in India. So even just our executive is spread across the world. And we are hell-bent on being global in the way that we think and being global in the information that we provide to our esteemed members as well. So thank you so much. Have a great evening. Mr. Patel, do you have some parting shots before we conclude?
So before we the closing, I have some remarks. First of all, again, thank you, Madam President, and it's great to be here. And you've been very kind for me, and thank you for all these wonderful arrangements that you have been. Again, all the participants, thank you so much for joining, and looking forward to seeing your work in Python, and looking forward for engaging much more a meaningful way in future. And again, Madam President, looking forward to have a long-term association in terms of work, in terms of Any other collaboration, I'm open to help in any other way. Thank you so much for having me again.
Thank you. Thank you so much. Thank you, guys. Have a great evening. See you at our next session. Bye.